All right, so we've been dealing mostly with sine, but the cosine really behaves the same. Remember, the graph of the cosine is just a shift of the sine function. And so we talked about this previously, that the cosine graph, if you just look at the cosine of x, is a graph that starts up at 1, then dips down, and comes back up. And so your 5 key points represent different things with the cosine than they do with a sine. With the cosine, the x-intercepts are the first quarter and the 3/4 points of the period, and the maximums are the first and last. The minimum is the center, the middle halfway point. Okay, so the cosine looks a little bit different when you just look at one period between the 5 key points. But outside of that, if you were to extend it, the graph's really going to be the same. It's just a shift. It's just a slide over by 90 degrees, or pi over 2. So, in fact, here, we're looking at a cosine graph instead. We've got an amplitude change, so we've got a 1/3 amplitude. We've also got some ugly fractions looking in here in the argument. Remember, to find the period in the phase shift, we need to factor the argument. First thing, if it's not already factored, some of these will be given to you in factored form, some will not. Must factor if it's not. So I'll give you some practice here, or an example how to do that. So let's see, I'm going to take it off to the side. I get 3 over 4x minus 3 pi over 8. Again, when you factor here, you want to pull out the coefficient of the x. So I get 3/4 times x minus, and then I got something here. And that something can be found by dividing the original constant by 3/4, or equivalently multiplying by the reciprocal. Okay, so if I take 3 pi over 8, multiply by the reciprocal, which is 4/3, right, reciprocal 3/4. The 3's cancel, the 4 and the 8 reduce, and I'm left with pi over 2. Remember, you can always check by remultiplying. 3/4 times x is 3/4 x. 3/4 times pi over 2, well, that's 3 pi, and 4 times 2 gives you the 8. Okay, so that should work out nicely. Let me get rid of this work, and we're going to take that and sort of rewrite this as y equals 1/3 cosine bracket 3/4 parenthesis x minus pi over 2 parenthesis bracket. Okay. All right, so that gives me the factored form of the argument. Now, I'm going to erase this work and find all these pieces of information here. Okay. So, let's see. Let's look at 2 pi over b for the period. Well, the b value is 3/4. So that's 2 pi over 3/4. b is 3/4. Well, if you divide by a fraction, it's multiplying by the reciprocal. So you could go with 2 pi times 4/3, right? Multiply by the reciprocal. And what's that? 8 pi over 3? Yeah, 8 pi over 3. Okay, so 8 pi over 3 is the period. Interesting. Then my phase shift is going to be the pi over 2. Good one. Okay, so there's my period and my phase shift. Of course, I know the amplitude to be 1/3 as well. So here finally, I want to get my, it's not really finally, is it? We got a long way to go. We want to get my 5 key points in. So the 5 key points again, 1, 2, 3, 4, 5. We're going to start at the phase shift, pi over 2, and then I add quarter of the period. Well, the period is 8 pi over 3. So 1/4 of the period is 1/4 of 8 pi over 3. And when I multiply those, the 8 and the 4 reduce, and that's just 2 pi over 3. 2 pi over 3 is 1/4 of the period. So that's what we're going to add to the pi over 2 to get each of our points. So I'll do that work over here on the left, then I'll erase it so I can plot the graph. So I'm going to start at the phase shift, pi over 2. I'm going to add 1/4 of the period, 2 pi over 3. I need a common denominator, which is 6. Multiply by 3 on the first fraction, 2 on the second fraction. That will be 3 pi over 6 plus 4 pi over 6, and that will be 7 pi over 6. 7 pi over 6, there we go. Then we take 7 pi over 6 and add to that another 2 pi over 3. Well, the 6 is already my denominator, so maybe I'll just use the equivalent 4 pi over 6 for this. Then I don't need to construct my LCDs again. That gives me 11 pi over 6. So that's going to be the middle point. Let's see, then we take 11 pi over 6 and add another 4 pi over 6. And that will give us 11 and 4 is 15 pi over 6. And 15 pi over 6, of course, reduces down to, if I cut them both by 3, it would be 5/2, 5 pi over 2. So that's going to be my 3/4 point. That's fascinating. I don't know why I'm finding this fascinating. But for some reason I am. I'm just making sure I did all my arithmetic right so far. So it's 3 pi over 6, add 4 of them, add 4 more, and add 4 more again. Yeah, okay, it's working out. I need one more point. So it's 5 pi over 2 plus another 4. Why would I do that? Why not leave the 6 on the bottom, right? So instead of using the reduced form, I'm going to use the 15 pi over 6 form and add to that the 4 pi over 6. That looks better. And so everything's in sixths. 15 and 4 makes 19. Yeah, okay. Yep, 19 pi over 6. So again, just double checking. I don't really want to make any mistakes here. So that is 19 pi over 6. Okay. All right, so as I'm thinking about this, I know pi over 2 is a nice value. I know 5 pi over 2 is 2.5 pi, so that's not too bad. And then we've got these weird sixths in there, but we can make that work. So let's do this. I'm going to go ahead and plot this out using my tick marks at 1/2 pi. I'll need 1 to get to the starting point, 5 of them to get here. I have some more out here, and then I can fill in the rest. I think that should work. It's going to look a little bit silly, maybe, but it should be okay. I could do pi's over 6s too, but man, I gotta have 20 of them or so to get out there. So let's not do pi over 2, or pi over 6. Let's just do pi over 2. I think that'll work. Okay, so let's plot this out. So I need, let's go out maybe 6 of them. 6 pi over 2s. So here's, what's 6 pi over 2s? It'd be 3 pi, right? So 3 pi, cut that in half, and that would be 3 pi over 2. And cut that in to, let's see, I said 6, right? So if I cut that, I got thirds here. Thirds and thirds. Okay, so this will be pi over 2, pi, 3 pi over 2, 2 pi, 5 pi over 2, and 3 pi. Okay, so it's increasing by half a pi on my scale. Of course, you could have negative pi over 2 and so forth going left. And now I've got to make sure my 5 key points are visible. So I've got my pi over 2, I've got my 5 pi over 2. In between those, this region here, if I cut that into thirds, I get my pi over 6s here. So that's going to be, so this region cut into thirds would be right about there. Maybe not quite that close to the center. So if that's 50%, right about there, maybe right about there, maybe? Yeah, roughly. Okay, so again, this one's going to have a little bit of a weird looking scale. I could make it better by going with sixths all the way out, but then it's going to get crowded. So I think this will work better. Okay, so that is, those are my two, the first quarter and the half, and I still need the 19 pi over 6, so that's going to be out from pi over 2 the same distance, so be out here on the other side of 3 pi. Yep, because 3 pi would be 18 pi over 6, so this is a little bit more than 18 pi over 6. Okay, that works. So now I need my amplitude. My amplitude is 1/3. Well, I'll give it a scale here of 1, -1, so if I cut those into thirds, that gives me my scale. Or my amplitude, sorry. So everything's going to be contained between positive 1/3, that needs to be a little lower, and negative 1/3. So the whole graph is going to be in that window right there. Now remember, with the cosine, we start up on top, go down, and come back up to the top. So my 5 key points, the first one here at pi over 2 starts up at top at 1/3, then it comes down to the axis, then down to the bottom, then up to the axis, and then up to the top. Okay, so that should give me my 5 key points. And remember, this is not, it almost looks like a V shape if I just fill them in, but I don't want to do that. I want it to be curved. So I'm going to start up the top here, curve down, through the bottom, back up. It's kind of wide, but that will work, okay? It looks kind of wide because really it's compressed by that 1/3 amplitude, okay? Again, I should put some ordered pairs in here on these weird points. Actually, all the points could use an ordered pair because it's not real clear just from the graph where everything is. Maybe my 5 pi over 2 is okay because I got that axis labeled. Everything else should probably get an ordered pair. So I'm going to put pi over 2 comma 1/3. This intercept is at 7 pi over 6. So that is 7 pi over 6 comma 0. This minimum is at 11 pi over 6 comma -1/3. Then here, this is at 5 pi over 2. That one's kind of obvious from the scale, so I won't write it in. And then this last peak here is at 19 pi over 6 comma 1/3. Okay. All right, I'm happy with that. That would work. Okay, so that gives us an idea of the phase shift, left to right. We're also going to deal with a vertical shift, okay? I'll show you a vertical shift in the next video.